So why do we do ETL? Again, obviously, whatever we do is for decision making. So the main reason why we do ETL is basically bringing data and make it ready for business decision making, for business, for analysis that helps us make better decisions. And again, bringing data from that raw format that it has into a form that can be now analyzed by our business intelligence tools. Through this process, we also always verify our data. We also, through ETL, can compare our data between source and target system. There could be changes, there could be some modifications, there could be some, again, lookup values that we need to bring in. So all of that can be done through ETL. And again, more importantly, ETL offers a historical context for the business. I mentioned this before, that the point of transactional system is not to keep track of history. The point of those systems is usually just to provide a system of records. So they keep creating records. It's a data warehouse that usually keeps track of historical data because historical data is usually needed for the sake of analytics. Again, transactional processing systems are not focused on analytics. Their focus is on making sure that they have a good record of our data. Once we move it to our business intelligence tools focus is on analytics, making decisions, and those are based on historical data. So that's why, again, ETL helps us, again, really migrate that data into a data warehouse, convert it into various formats that's required, and also it keeps a history, you know? So obviously, we talked about this multiple times. So ETL stands for extract. So data is being extracted. These are exemplary sources of data. Our relational databases, our non-relational databases, our cloud platforms, our XML files. We extract that data, bring it into the staging area. We transform it, do whatever that's necessary. So extract, and then it's loaded to, once it's loaded to the data warehouse, then it can be analyzed for analytics. So let's talk about these 3 steps. So the first step of ETL, it's called, actually, you know what? Before I go through these, let's watch that as another short video, and then I will talk about these steps.
Google Fi, a phone plan by Google. It's easy to switch to Fi from the comfort of your home.
Hi, I'm Jared Hillam. Today I want to offer up a challenge to all those that are watching this video. Find something in the room you're in that has never had any data associated to it. Go ahead, look around. Unless you find yourself watching this in the middle of no man's land, chances are that a very high percentage of everything around you has been represented by data at some point in its life cycle. That's pretty amazing, isn't it? So in many ways, you can imagine that our digital world of data is a representation of the physical world around us. And indeed, it would be nearly impossible for organizations to accurately describe themselves if they didn't have access to this type of data today. And just as organizations need to manage their physical assets, they likewise need to manage their data assets. After all, they are a representation of the physical world. And this is the point where I introduce you to something called an ETL tool. ETL stands for Extract, Transform, and Load. Just as its name implies, ETL tools extract data from a source, transform the data while in transit, then it loads the data into a target storage of choice. These movements of data can be scheduled on a regular basis or triggered to occur. The types of projects that ETL tools are used for vary greatly, as these tools are built to be very flexible. Some common projects would be rolling up transaction data for business people to work with, which we commonly call data marts or data warehouses, migrating application data from old systems to new ones, integrating data from recent corporate mergers and acquisitions, and integrating data from external suppliers or partners. The list of possible uses for an ETL tool extends well beyond the scope of this presentation, but hopefully you'll walk away from this video with an appreciation for how critical these systems can become to the day-to-day operation of a business. To highlight life without an ETL tool, imagine having to be an expert at every source of data your organization owns and trying to hand code all the data movement requirements we discussed earlier. Now here is where I want to provide a warning. When you use an ETL tool, you will marry your organization to it. This is because a large body of logic will be designed in the data movement process, and it will become part of the lifeblood for running your business. So the purchase and use of an ETL tool is a very strategic move, even if it's intended for a small tactical project to begin with. So before you marry yourself to your ETL tool, make sure that you're not painting yourself into a corner, as ETL tool migrations are no small effort. Here are areas that you should focus on in determining which ETL tool to choose. 1. Data connectivity. ETL tools should be able to communicate to any source of data, no matter where it comes from. This is critical. You may not have mainframes in-house today, but all it takes is an acquisition of another organization to all of a sudden need to get access to those types of systems. 2. Performance. Moving and changing data can require some serious processing power, so it's important that your ETL tool can scale with its future data growth. 3. Transformation flexibility. Matching, merging, and changing data is critical. ETL tools should provide these and many other package transformations that allow modifications to be made to the data with a simple drag and drop movement. 4. Data quality. Your data isn't clean. I can guarantee it. You will need support for data profiling and data quality, including the ability to validate addresses. The only way you can leverage your data to deliver information is if your data is consistent and clean. 5. Flexible data acquisition options. Once you have your ETL environment developed, you'll want the flexibility to determine whether your data is acquired on a time interval or based on a trigger. This also means that you'll want the flexibility to determine what data gets pulled, whether it's just the new data or all the data at once or even a specific subset of data. 6. Committed vendor to ETL. Remember, you're about to marry yourself to a tool. Be sure your spouse is committed to data management and all the activities around it. Intricity partners with its customers to evaluate which tools will best.
Okay, so ETL tool is basically the software that will help us do all kind of that transformation, right, and the data integration. And we are going to use different tools in this course. Again, depending on your preferences, there are various tools available. I think I might have time to cover one or two in this course, but I will provide information about most of them, so feel free to use any of them for your project. So ETL is basically, it's that process that can be handled by software or can be hand-coded. Example of hand-coded was the code I showed you first, the Python code, but also you can use different code, different software that will do all of these activities. But let's talk about now these processes. So what would, for instance, the software will do for you? First thing first, you need to bring data from a source system into what's known as the staging area. There are two reasons why we do this. First of all, we want to make sure that our source systems perform and run without any interruptions. When I say source systems, it could be like, for instance, our ERP system, our transactional processing systems. Those are systems that you need to use for our day-to-day activities. We need to make sure that the performance of these systems not degraded. And if you start analyzing data within those databases, it will affect their performance. So we need to bring it into the staging area. It's a separate platform in order to do the transformation. Second, if corrupted data is copied directly from the source into a data warehouse a rollback will be very challenging. So it's important that we bring that data first into a staging area, which will give us an ability to validate it. And once the data is validated, then we move it into a data warehouse. So again, data warehouse gets its data from a variety of systems that are different in terms of the database management software, the hardware, the operating system, the protocols that they're working with, the standards that's set for them. We saw some example in that data file, in that Excel file I was showing you. This is an example. This is what I mean when I talk about variety. And this is only one dimension, or maybe two dimension, in one dimension, one fact table. Imagine if we have tens of these dimensions and fact tables. What do we do then? So first thing first, we need to make sure it's validated before it comes to into our database. So there are different ways that we extract data. It could be a full extraction, meaning that we read the whole database and bring it into the staging area. An alternative to that would be a partial extraction, especially when we are thinking of the slowly changing dimensions. We only want to see what's been updated over time. And those examples, we do partial extraction. And in terms of validation, once we bring it in, what would we check? Again, these are examples. There could be many more. We want to, for instance, reconcile records with the source data. We have some data. There's been some changes to it. We want to make sure it's consistent with the source data. We want to make sure there's no spam or unwanted data that unintentionally being loaded into our data warehouse. We want to check the type of data that, let's say, we have a column called date of employment. We want to make sure if it's in the date format. Maybe a few of them are missing or not consistent. Also, it's very common to have duplicates. Let's say we're thinking about our customer data. It's coming from different sources. One is from our HR system. The other one would be our a customer table from a CRM system. Another one would be a customer table in the ERP system. We want to make sure that there's no duplicate in this data. We want to make sure it's consistent. And also if all of them have keys, maybe some of them are missing, or there might be some inconsistencies in terms of keys. We have two records of customers we have two records of the same customer, but there's two different keys associated with this. How do we reconcile that? So that all happens in the first step, which is extraction. The second one is what's known as now transformation. The transformation, once we extract data, as I mentioned, it's like over 90% is raw. It's unusable in its original form. We need to clean it, we need to map it, and then we need to transform it. The key step of ETL is basically this transformation, where we might end up changing some of the values or cleaning some of the values, but this is where we make sure that the data is the kind of data that will give us the insights that we need in the business intelligence tools. Now, sometimes I would say not often, but like sometimes it happens that the source data is also very similar to the target data. In that case, we call it a pass-through data. But again, based on at least my own experience, this is not something that happens very often. All right. But let's see some of the issues that happens during the transformation. Let's say we're bringing data from different sources. This is bank information. We have a system for saving, loans, trust, credit card. It's possible that the same data is called different. Let's say in this one, for instance, one's called account information, the other one, it's called account credit card information. It's the same data set, but the name of the column tables are different. So we have to kind of make them consistent. Or the other way, in one system, it's called client last name, and the other one is called bank customer's last name. It's same data, but the name of them are different. So we have to like reconcile those. Or data found is data found here, nowhere else, different keys used for the same data. For the same, for instance, rows, we have different keys. So these are examples against some of the issues. I have a simple exercise we can do later on just to see what kind of issues might happen. But again, other examples, let's say we might have a spelling errors in first name, right? We have John, but H is missing. Or we have multiple ways to write the name of a company, like Google Inc. It's the same company, maybe it's the same customer, it's written differently. PepsiCo, Pepsi Company, same client, different name. Or there might be like small errors, small typos, like Cleveland, right? Person meant the same thing, but there's some typos. There might be even the same case if we have different account numbers are generated by different applications for the same customer. What do we do then? Or different customer ID for the same customer. Or some data have no values, right? That happens also too. There's some missing information. What do we do then? Now, in terms of validation methods that happens during transformation, again, these are not all inclusive, but covers most of the practices. We might want to do filtering, right? I mentioned to you, this database or this data warehouse is focused on not customers in the northeastern region. We do some filtering. We want to look up zip codes based on the addresses or based on the cities they reported. We are using character set conversion. Let's say, again, the same thing with the last name. We want to make sure the first name, last name is in capital format. We want to change some unit measurements. Maybe there's some distances in the shipping that were reported in kilometer. Now we want to convert it into miles format. Or date and time and currency needs to be changed for whatever reason. Our sales data coming from different countries all need to be converted into US dollar, for instance. There's a threshold validation check. Let's say we know that our customers are all between 18 and 65 for whatever reason. Anything that has been reported above or under is either an error or is an unacceptable value. It goes into the rejected table. Remember the rejected table? Or data foundation cleaning, removing, for instance, null values, or if the gender, for instance, is male, reported male, we turned it into M, or if it's female, we want to report only F. We might want to split some columns into multiple tables. Let's say we have one column that has the full address, but now we want to convert that into multiple columns with the street number, street name, and then city, and then the state, right? So we're splitting the column. We might transpose rows and columns. We want to merge some data, or we might have to do some complex kind of processing. That would include a mix of these, maybe some aggregation and validations and cleaning. And now in the loading stage, that's where the transformed data is going to get loaded into our data warehouse database. In a typical data warehouse, as I mentioned, we are dealing with huge volumes of data that needs to get uploaded or updated, typically after hours. Again, we mentioned that we don't want to interfere with performance or other systems. So most of these activities are usually being done when transactional systems are not working. So it's over night or between the rest time of other systems. Now, I mentioned to you that it's the performance matters a lot. So for our data warehouse also to work good, it's important that we optimize our data loading with regard to performance. Again, if there's some normalization or denormalization that will help processing our data, that needs to happen here. In most cases, we're talking about a little bit of denormalization for the sake of performance. And related to the way we are handling changes, and we talked about those last week, there are different types of loading. If it's the first time we are populating our data warehouse, we're doing a full initial load usually, but incremental load typically applies to the ongoing changes or maybe some updates to certain data that usually happens periodically. And a full refresh is when we are replacing one or more data tables with fresh data. And this is an example of the type 1 change. So the type 1 slowly changing dimensions, full refresh, or it could be initial load. An incremental load is basically type 2, type 3, or even type 4, if you remember what type 4 was about.